You think time is a steady river, always flowing, 1 second after another. You imagine clocks as honest machines. They tick the same everywhere. On Earth, in space, near anything, you imagine time as a background, a stage the universe plays on, unmoved by what happens on it. This is wrong. You think falling into a black hole would tear you apart first. That time comes later, as an afterthought. But the first thing that breaks is not your body, it's your sense of now. You imagine slowing time as a metaphor, a figure of speech, a poetic exaggeration. It isn't. Near a black hole, time does not feel slower. It is slower, objectively, precisely. And if that makes you uncomfortable, it should. Should I proceed to the chapter breakdown? You assume a second is a second, not emotionally, not psychologically, physically. You assume that when a clock ticks, it reports something real and shared, something everyone agrees on. If your watch says 10 seconds passed, you believe those same 10 seconds passed everywhere else in the universe, on a satellite, on Mars, near a star, near a black hole. This assumption feels so natural, it barely registers as an assumption at all. It feels like a definition, but it isn't. A clock does not measure time in the way a ruler measures length. It does not reveal something that already exists, waiting to be read. A clock creates time locally. It reports how fast reality is unfolding right where it sits. This is not philosophy. This is physics. If time were universal, we would expect all clocks to agree. Always, not approximately. Exactly. A disagreement of even a billionth of a second would mean something fundamental is wrong with our picture of reality. And this is where the picture collapses. We already live in a universe where clocks disagree quietly, constantly, even here on Earth. Clock on the floor runs more slowly than a clock on a shelf. Not by much, but measurably. Atomic clocks confirm this every day. Engineers building GPS satellites must correct for it, or your phone would drift kilometers off course. This is not because the clocks are faulty. This is because time itself is uneven. The discomfort comes from how ordinary this should feel and how wrong it does. You are not used to thinking of time as something that changes speed. You think of it as the thing against which change is measured, but that ordering is backwards. Motion does not happen in time. Time adjusts to motion and gravity. It bends, it stretches, it slows. Once you accept that clocks can legitimately disagree, the idea of a single universal now quietly dissolves. There is no master clock ticking for the universe, no cosmic stopwatch keeping everyone honest. There are only local clocks, each faithful to its own patch of reality. Near a black hole, this stops being subtle. Near a black hole, the difference is not billionths of a second, it is hours, years, centuries, entire lifetimes. The mistake is thinking this is an extreme case. It isn't. It is the same rule, applied without mercy. You think gravity pulls downward, inward, toward mass. You imagine an invisible force reaching out from objects, tugging on everything nearby. The Earth pulls you down. The sun pulls the planets inward. A black hole pulls hardest of all. This picture is comfortable. It feels mechanical. It feels complete. It is wrong. Gravity does not pull things through space. It reshapes space and time themselves. And time is the part that quietly breaks first. Einstein's mistake was not discovering something new about gravity. It was realizing that gravity had been misunderstood all along. What we call gravity is not a force acting within space-time. It is space-time refusing to stay flat. Mass does not reach out and grab you. Mass changes the geometry of reality around it. Objects simply follow the straightest possible paths through that distorted geometry. This is already strange when applied to space. But space alone cannot explain what we observe. If gravity only bent space, clocks near massive objects would behave normally. They do not. Time bends with space, inseparably. This is the part your intuition resists most. You expect mass to affect where things go, not how fast reality unfolds. You expect gravity to influence motion, not duration. But space-time is a single object you cannot bend one half without deforming the other. When mass curves space, it necessarily stretches time. Near Earth, the effect is gentle. Time runs slightly slower at sea level than on a mountain. The difference is small enough to ignore in daily life, but large enough to break satellite navigation if left uncorrected. Near a black hole, there is no such mercy. As mass becomes more concentrated, space-time curvature intensifies, the geometry steepens. Paths warp more severely. And time, always coupled to space, slows dramatically, not symbolically, not perceptually, physically. This is why black holes are not defined by darkness or density, but by time. The defining feature of a black hole is not what it does to matter, but what it does to clocks. At a certain boundary, time slows so much relative to the outside universe that escape becomes impossible. Not because gravity pulls too hard, but because time itself collapses inward. You do not fall past a black hole's edge in the way you imagine. Time fails before motion does. This is the first place your intuition gives up. Because once gravity controls time, there is no longer a universal order of events. No shared rhythm. No agreed upon flow. Only local unfolding. And near a black hole, that unfolding nearly grinds to a halt. You imagine disagreement as confusion. One observer is wrong. The other is right. Reality settles the argument. This expectation fails near a black hole. Imagine a simple setup. No equations, no machinery, just two observers and two clocks. One of them stays far away from the black hole, watching safely from a distance. The other begins a slow, controlled descent toward it. No dramatic fall, no acceleration, just a steady approach. Both start with identical clocks, perfectly synchronized. At first, nothing seems strange. Signals pass between them. Each sees the other's clock ticking. Slightly off, perhaps, but close enough to ignore. Then the descent continues. The distant observer notices something unsettling. The falling clock begins to tick more slowly, not abruptly, gradually. Each second stretches. Each signal arrives more delayed than the last. This is not a Doppler effect. This is not motion causing lag. Even if the falling observer fires engines to hover, the slowing remains. Time itself is changing speed. From far away, the descent never quite finishes. The falling observer appears to slow, then freeze, suspended just above the black hole's edge. Their clock seems to stall. Seconds blur into stillness from a distance they never cross. Now reverse the perspective. The falling observer sees nothing unusual. Their clock behaves normally. Their thoughts proceed at a familiar pace. The universe outside looks accelerated but coherent. The distant observer's clock races ahead. There is no moment of freezing, no sudden barrier, no warning. They cross the boundary in finite time. Both descriptions are correct, not approximately. Exactly. This is where your intuition collapses. You expect there to be a single story of what happened, a definitive answer to whether the crossing occurred. There isn't one. There is no contradiction, because there is no universal time against which events must align. Each observer carries their own timeline, and gravity decides how those timelines relate. The black hole does not break time. It exposes what time always was, local, flexible, observer-dependent. You are used to disagreements being resolved by better measurement. Here, better measurement deepens the disagreement. No signal can reconcile the two perspectives. The slowing of time prevents it. Information itself gets trapped in the distortion. This is not an illusion. Not a trick of perception. It is not about how things look. It is about how reality unfolds differently in different regions of space-time. Near a black hole, asking what really happened stops making sense. There is no single answer. Only different clocks, each telling the truth where they are. You expect destruction to come first. Tidal forces, spaghettification, torn apart. You imagine time slowing as a dramatic side effect. A strange consequence that shows up after everything else has already gone wrong. This ordering is backwards. Near a black hole, time does not slow because gravity becomes extreme. Gravity becomes extreme because time is slowing. This sounds like wordplay. Isn't. A black hole is not defined by how dense it is or how violently it pulls. It is defined by a boundary where time, relative to the rest of the universe, grinds almost to a stop. Long before atoms stretch or bodies break, clocks begin to fail. From the outside, everything approaching the black hole appears to move more slowly, not just in motion, but in existence. Processes drag. Changes hesitate. Events lose their urgency. This is not because objects are struggling against a force. It is because the future is becoming harder to reach. Time is the dimension that allows change. When time slows, change slows. Motion, decay, reaction, all of it depends on time being available. Reduce time and everything else follows. This is why light itself struggles. Not because gravity grabs photons, but because the path forward in time is narrowing. Light is forced to spend more of its existence climbing out of distorted space-time. Eventually, it cannot. This is the origin of the event horizon. Not a wall, not a surface. A region where time is so distorted that all possible futures point inward. Once this happens, escape is not forbidden by force. It is forbidden by geometry. Nothing dramatic occurs at the boundary locally. No alarms, no physical marker. The falling observer notices nothing special at the moment time disconnects from the rest of the universe. But from the outside, the story has already ended. Time slowing is not a symptom of black holes. It is the mechanism that creates them. This is deeply uncomfortable because it reverses causality in your mind. You want gravity to cause time dilation. In reality, they are inseparable aspects of the same structure. Matter warps space-time. Space-time dictates how time flows. Time flow determines what can happen next. Near a black hole, next loses its meaning. Events still occur locally, but their connection to the wider universe thins until it vanishes. The collapse into a black hole is not an explosion or a crushing. It is a quiet severing of timelines. Time goes first. You believe in now without thinking about it. You assume that whatever is happening to you is happening with the universe at your present moment, while personal, is still part of a shared slice of reality. Different places, same now. Near a black hole, this assumption fails. From far away, an observer watches an object fall toward the event horizon. At first, everything behaves normally. The object accelerates. Light reflects. Signals arrive on schedule. Then something strange happens. The falling object begins to slow, not just in motion, but in progression. Each signal it sends takes longer to arrive than the last. Its clock ticks more slowly compared to the observer's. Movements stretch. Actions hesitate. The object never quite reaches the horizon. It freezes. From the outside, the fall becomes incomplete. The object appears suspended just above the boundary, dimming and reddening, locked in a perpetual approach. No single moment marks the crossing. No final update is received. To the distant universe, the object is always about to fall in. But this is not what the object experiences. From its own perspective, nothing unusual occurs at the horizon. Time flows normally. The fall completes. The boundary is crossed without drama or delay. There is no freezing, no hesitation, no infinite wait. Both descriptions are correct. The contradiction exists only if you insist on a shared now. What the black hole reveals is that now is not universal. It is local. It belongs to paths through space-time, not to the universe as a whole. Near the event horizon, different observers stop agreeing on which events are happening at the same time. The falling observer's present moves forward smoothly. The distant observer's present never includes the moment of crossing. There is no single slice of reality that contains both. This is not a trick of perception or a limitation of instruments. It is a structural feature of spacetime itself. The geometry near a black hole tilts time so severely that futures diverge. For the falling observer, the horizon lies in their past moments after they cross it. For the outside universe, that same event lies forever in the future. And futures that never arrive might as well not exist. This is the true meaning of frozen at the edge of a black hole. The object is not stuck in time. It is stuck in someone else's future. The idea of a shared present dissolves. There is no master clock ticking for the universe. No cosmic, now everyone inhabits together. There are only local timelines stitched together where space-time allows. At the event horizon, the stitching fails. One observer keeps falling, another keeps waiting. Neither can meet the other's present again. Now does not end everywhere. It ends where agreement becomes impossible. And the black hole is where the universe finally admits that there was never just one to begin with. We assume cause comes first, that events are neatly ordered. Something happens, something follows, consequences unfold. It is the foundation of thought, action, and expectation. Near a black hole, this foundation trembles. Time slows unevenly, not gradually everywhere, but locally, relative to the universe. What was once a simple chain of events becomes a tangle of sequences that cannot agree on order. The falling observer experiences a smooth progression. Each action leads to the next. Decisions have consequences. Yet to the distant universe, that same chain stretches, delays, and seems to lag behind itself. Signals from the fall light, radiation, information are no longer reliable markers of sequence. The same event can appear to happen before or after another, depending on who is observing. For the outside observer, cause hesitates, effects drift. One can see the beginning of an event unfold, while the end remains locked away in the slow crawl of dilated time. This does not violate physics. Relativity allows for these differences. The equations still balance. Energy is conserved. Nothing unphysical occurs. What breaks is intuition. What breaks is expectation. The mind that assumes a universal next struggles when the next moment itself is no longer universal. Inside the black hole's pull, the falling observer can make choices, respond to stimuli, experience consequence. Locally, cause and effect are intact. The mind perceives sequence. But those same actions are effectively quarantined from the rest of space-time to the universe at large. Cause and effect fracture, disconnected by the narrowing of time. The future recedes faster than influence can reach it. The past stretches into inaccessibility. This blurring has profound implications. Communication fails. Predictability fails. Observation fails. The distant universe cannot say what will happen next, because its next is not the observer's next. The observer cannot warn the universe, because the signal cannot escape the warped corridor of time. Each is trapped in a private causal bubble. Imagine trying to play a game when the rules shift depending on your position in time. Imagine trying to plan when the future you reach is no longer the future everyone else experiences. This is the reality at the edge of a black hole. Cause and effect are still present, but they are no longer shared. They are local phenomena, intimate to a path through space-time, invisible to outsiders. In this way, the black hole does not destroy order. It dissolves agreement. Physics remains intact, but the universe stops agreeing on what comes next. The flow of time bends, and with it, the narrative of events becomes personal, fragmented, unrepeatable. The universe cannot watch its own consequences. Events that are causes for some are invisible effects for others. The familiar arrow of time, the backbone of experience, twists until it points only inward. And in that inward twist lies the quiet terror of the black hole. Cause and effect survive, but only for those who cross the threshold. For everyone else, the story has already ended, or perhaps never truly began. You were taught that time flows, that it moves steadily, universally, like a river carrying everything forward together. You were taught that now is shared, that cause leads to effect, that the past is gone and the future awaits. None of this is true. Time is local. It is a property of the path you follow, not a gift the universe distributes evenly. Each observer carries their own temporal thread. Black holes reveal this truth in extreme relief. One path slows, stretches, diverges, another proceeds uninterrupted. What happens to one does not necessarily happen to the other. The horizon does not crush objects. It does not obliterate them. It quietly disconnects them from the temporal consensus. Clocks inside tick normally. Events unfold normally. Choices retain meaning. But their consequences, their connection to the wider world vanish. The outside universe cannot read them, cannot respond, cannot remember. Time was never a single arrow. It was never a river. It was always a collection of threads, woven together where space-time allows, unraveling where geometry forbids. The notion of a universal present, of a shared progression from past to future, is a comforting illusion. The black hole shows it is not reality, it is only a perspective. This does not make existence meaningless. It only changes its scale. Each timeline remains coherent. Each observer experiences continuity, memory, thought, perception, all continue uninterrupted. What is remarkable is that such ordinary processes can persist even when the universe refuses to agree on their order. A black hole is not a punishment. It is a teacher. It does not destroy. It reframes. It reveals that the familiar ideas of before and after, cause and effect, here and now, are not universal laws, but local conveniences. Reality is stranger than intuition, more intricate, more intimate, more private. The awe lies not in what is lost, but in what continues. Time can diverge, time can fracture, and yet life, in its local bubble, still finds a rhythm. History still accumulates. Choices still matter. Even at the edge of cosmic oblivion, the universe allows existence to persist not universally, not openly, but locally, in ways the mind must struggle to comprehend. Time was never what you thought it was. It was never a river. It was always a mosaic, threads weaving, separating, and occasionally disappearing from view. And the black hole in its quiet geometry is the ultimate reminder reality is larger, stranger, and more beautiful than any shared clock could ever measure.